Welcome, everyone, to the fourth edition of the Responsible AI web series that are presented to you by Xomnia and Itopia. So last time in our Sustainable AI webinar, we actually discussed ways to make your neural networks less power hungry. And so this time we actually have two great speakers again who will talk about two different topics. And so first we have Lucia Loher, who is the product lead of Jina AI, and she will give us an introduction into the open source search engine. And then following Lucia's presentation, we will hear a keynote from Ricardo Vinuesa, who is an associate professor and also affiliated researcher in the AI Sustainability Center at the KTH Royal Institute of Technology in Sweden. And he will actually dive into the background behind his research on the role of artificial intelligence in achieving the Sustainable Development Goals. And so if you have any questions during the presentation, please just send them into the chat and we will address them after each talk. And so this edition of the Responsible AI web series is organized by Mark Berger and myself, and we collaborate actually with Marika Peters from Xomnia, who leads the whole Responsible AI series. Yes, so to give a quick introduction about myself for those who haven't joined one of the last webinars. So I'm a data analyst at Adyen, and I'm very curious to actually learn more about sustainable and also responsible AI. And I would also like to create more awareness about the topic within the AI community. And so therefore, Mark and I started a new initiative called Itopia, just really out of pure interest and curiosity for the topic. And so with Itopia, we want to focus on green and sustainable AI. And we would also like to build a community made up of research and also industry professionals to connect people and also spread the message of green AI practices. And that's also why we help to organize this series. And so if you have any questions or would like to contribute to that, please just feel free to reach out via mail or LinkedIn. And now Mark is going to introduce himself next.
Thanks, Natasha. My name is Mark Berger, and I work as a data scientist at FIOD, the Dutch investigation and anti-fraud agency. And I have an academic background in AI and information systems. And just like Natasha said, I'm also interested in these topics revolving around responsible and sustainable AI and how can we contribute to a better future by employing our AI knowledge. So now I want to shortly introduce the Itopia initiative. The Itopia initiative that we are currently setting up will involve a dedicated website where we will post some content, and we will hopefully also create space where people can engage with each other on these topics of, for now, sustainable and green AI, but later maybe also ethical and responsible AI. And I have some QR codes, but the website is actually really easy. It's just itopia.world. For now, it's just a landing page where you can reach out to us, but we are in the process of building that up. So it would be wonderful if you would connect with us and leave us a message what you think about the initiative. And now we will go on to the start of our webinar with our first guest speaker, Lucia Loher. Like Natasha just introduced her, Lucia is the product lead for Jina AI, an open source neural search company. And their quest is actually to democratize neural search process by developing this big end-to-end framework, which Lucia will dive into in a bit. So if you have any questions during her talk, please use the chat function and we will just moderate your questions after the Lucia's talk. And now I give the floor to you, Lucia. You are still on mute, Lucia. That's fine.
Now I feel like every Zoom call over the past 8 months developing my product. So I want to say thank you and thank you for the warm welcome. I said my name is Lucia. Besides being the product lead in Gina, I also am quite the activist for ethical AI, and I'm also getting interested a lot in sustainable AI. So I'm super excited to speak in front of all of you and kind of share my personal vision why I believe that Gina is quite, the accelerator for a more sustainable AI and a more sustainable AI supply chain. So before diving into what Gina does, I do want to set a little bit of the context of, why that is and, how I see kind of the entire AI supply chain and how Gina fits in with its neural search framework that we also open source. So, very bright. So basically, the first thing is to look at the current state of AI and the market. And while we still see a lot of it being hardcore engineering-driven, investments from 0 to 1, with a whole host of new like pre-trained models coming in to the market every day or every month nearly, we also see that a big shift, especially in neural networks and deep learning, is about reusability. So we're trying to move away from like the first engineering into really creating a more engineering-driven version of reusable AI models. And so basically, this is kind of where the state is and where we are. And so how does that look from like a supply chain, and where does Gina fit in? So I call it a sustainable AI supply chain, in the sense that we do know that training AI algorithms is incredibly resource intensive. I've heard the myth that the GTP2 has cost, to develop it has cost over 4 million, not just in money, it's resource intensive, also obviously on infrastructure. And so we know that only a few big companies, big tech giants can actually produce these type of pre-trained models. And then what we do see is that they provide these pre-trained models. However, in order for them to actually be useful to the broader world and community, there need to be like these type of accelerators that are here called rest of AI community that will basically take these pre-trained models and make them applicable to actual AI solutions that we see, no matter what it is, from like Alexa to self-driving cars to anything. There is like this middle layer. And that's basically where I believe Gina kind of sits. So Gina sits and provides design pattern or a framework that I'm going to talk about in a little bit more detail in a couple of seconds, that we're open sourcing. So basically we're trying to help, as I think Mark said, democratizing the access to these type of solutions for the specific space of search. And while this might seem rather a small space, search is kind of I think that it's the underlying technology that can be used for just like an infinite amount of different solutions, from navigation to chatbots to just anything like could be translated into search and information retrieval. And so I think this is really where we can help get the industry adopting like these pre-trained models instead of creating their own solutions. So this is really kind of two ways of how we're helping, by democratizing it, the access, and by also including a lot of the models, and we get there as well, a lot of the AI models, the pre-trained models that are existing in the market in our framework. So they are there in our hub, ready to use and implement in different search solutions. So let's look at what Gina does and how we do it and what it is. So basically, we have a couple of value propositions, kind of what are we trying to solve for, that I wanted to start with first before diving in. And the first one is universality. So we really try to include a lot of different data types. So that's the first part of universality. So we're supporting image and text and video, but we're also trying to support a lot of different libraries, like PyTorch and so forth. So there's like a whole host of different things that we are supporting. Cloud native is by design. We will see how Gina works with, like how Gina looks at search flows. Flows is our concept. But each piece of the solution or each piece of Gina is actually like a small microservice that you can containerize and deploy anywhere you want. So it really is by design cloud native, and it's very easy to scale it on cloud as well. Time saver is a really nice one because we are providing an end-to-end solution of how you do search from a document to the index and from the index back to your matches. And that really should be hopefully very time-saving for all the different developers building on top of our solution. And last but not least, plug and play goes back into kind of the notion that I just mentioned about the pre-trained models. And basically, lays out that we are allowing people to bring their own models and plug it into our search system, but also using a lot of the pre-trained models that exist out there. So basically helping people that they don't need to retrain themselves, but can actually use the goodness of models like FICE and SCAN to leverage these models in actual search systems that they can build on top of us. So some couple of clarifications on what we really mean, because when we say framework and design patterns, so just kind of as a frame of how we think about these words, because they always mean different things. So when we say framework, what we basically mean is that there's a pyramid of different things. So you have the technical infrastructure with hardware, and then you have frameworks. And then you have, at the very end, you have end-to-end solutions. So Gina very much is not an end-to-end solution. It's not a SaaS that you can just deploy to get a recommendation system. That's not what Gina provides. Gina provides a framework, a way of doing things that will help you plug in. It's like a toolbox, really, where you can plug in your own AI search model. You can plug in your own data, your own environment, and really make it work for your domain space. And so the second thing, though, that is very powerful when we talk about Gina is the design pattern part. And we chose to have it side by side and look at it like programming. So when you look at programming and the way programming has the evolution of programming with this, there were different design patterns. So we went from structured programming into object-oriented programming, and then lately into concurrency-oriented programming. And just like that, search has evolved very similarly. When we look back at the very early stages of search, you saw a lot of catalog-based search. And then only a couple of years ago, well, 20 pretty much, there came symbolic search, key value-based search with inverted indexes that made it a lot faster to search for different things. And so Gina introduces neural search, basically also called semantic search or vector similarity search. We will look into what that means in just a second, but basically introducing a new design pattern that makes it a lot easier and faster to actually store data and then retrieve it, because you don't need to come up with all these business rules of how to find your data again, but it's trained. So let's do a very simple overview, and because I'm limited on time, it will all be very introductory of what neural search is. It's all about embeddings. And so basically what it means is that when you have data coming up, like WhatsApp or 25 years in my, like this is basically text from a music lyric song. What happens in Gina is that it will parse it apart, and what it basically creates is embeddings that are then projected into or saved into a vector space. And so it does this with the data that you're indexing. And then at query time, when you look up the exact same words or similar words, what it happens is that the exact same type of data, data analysis or data, how do you say it? Like transformation happens, and it will also be embedded into a vector and projected into the same multidimensional vector space. And then based on different algorithms, like for example, nearest neighbors, it will calculate the actual distance to each other, and it will come up with the answer to your match, or the match to your query that is the closest to the original one. So this is basically the heart of Gina and the heart of neural search. But Gina provides more than just a vector indexer or a vector indexing space or database. It actually provides the entire end-to-end solution. And the first thing to kind of look into when we talk about how it provides this end-to-end concept or framework, is looking into the flow concept. And this is really like the intro of what Gina does. But basically in the flow concept, we have this very lovely visual way of representing what happens with search. So we already talked about flows being like having different kind of microservice, containerized, what we call pods. And these pods are these independent pieces of the entire flow that are actually just wrappers around what we call peas, because it's just conceptually nice if you think about the plant, as you can see with the peas and the pods. And they are actually the logic and the intelligence of the entire flow. They happen there in drivers and in executors. But let's move from top to bottom on these. So the first thing I talked about is the flow. So this is basically the concept of the task manager, the context manager. So we have 3 different flows currently. We have the indexing flow that allows you to index data, going from document to an indexed store. We have the query flow, which allows you to query data, the same that you like, not the same, but based on like the index, and gives you matches. And we also have the evaluation flow, which is a rather new concept that allows you to evaluate the entire flow and fine-tune it so that your results get better and better over time. And as I just said, the flow consists of pods, and basically these pods are they actually like doing the actual hard work. We get into that in a second. And the flow is the pipeline managing, telling the pods who to talk to next. So basically how to transmit information from one to another. The second piece of what we're doing and how we're doing it is the pod. That is actually, the pods are actually the brain of the actual flow. That's where everything, the functional units, where everything happens. And, they consist of different Ps, but they're always the same functional Ps. We have drivers as well in there. Drivers are the ones that are basically the message manager. That when from one end to another. So when pods talk to each other, like there's always one that decodes the message from the previous pod. Then we have an executor that does some transformation on the data. And then we have another driver that allows you to speak to the next pod. So this is basically the way they work. And so let's, as a last piece, I also wanted to quickly go over how, like, what are the most common pods and executors in a search flow. So what do we usually work with? So in these different ones, so we usually have, and this is not like a definitive list, we have some other pods and executors in our hub as well. But we usually have a crafter, some sort of crafter that basically allows you to transform documents into like chunks, or like transforms it into a data format that works well for the search pipeline. We have segmenters that segment documents into, or cut documents into smaller pieces. You can think of, for example, an image being broken down into pixels, or a long text being broken down into sentences. All of these are done in the segmenter. The encoder is the heart. That's also where a lot of the AI algorithms come in, because they help represent these chunks of documents into a vector embedding. So when I just talked about the vector embeddings, and this being, the neural search part of it, this is where it happens. And then the indexer is basically saving and retrieving these vectors and key value information, the meta information of the document, from storage. Rankers is the last piece that usually is quite important and quite powerful as well, is how you sort your results. So you can have different types of rankers depending on what you want, like if you want to include additional business rules into your search. So this was like a long breath of a first introduction of what Gina does and how the framework works. So just as a couple of last thoughts, I also want to say, so we have the core, which is our open source framework that I just introduced. There's also some other couple of like products that we have at Gina. The second most important one, I would say, is the hub. I talked about the plug and play aspect. I talked about how AI algorithms are shared between us and the community, but also between different community members, and that all happens in the hub. So if you have a pre-trained model, you can easily build your hub image around it, and then you can share it with the community. And that really accelerates the use or the application of Gina in different industries. So this is especially important if you have different applications like NLP or computer vision. All of these different executors or pods live in the hub and can be leveraged there and pulled into your search solution. And last but two more things, we have the dashboard. The dashboard is really useful for two main things right now. So we have the monitoring aspect of it, which is basically debugging. So we have a logging system there, and you can really dig into your search solution, find out how it works. But we also have like a flow visualization tool that is absolutely fantastic for people that are not Python kings and are getting started, or CLI focused folks, or just non-coding people, because it allows you to build flows from scratch using nothing but like a easy drag and drop user interface, and deploy it as well. So this is really neat. The box is the last piece of our current ecosystem. And we have, so there it's really all about surfacing these, to have a front end for your search engine. So say you have you're basically building up your own search engine, and you need a pretty interface to be able to actually do the search. This allows you to do that. All of these things are completely open source for you, free to use and try out. Okay, last comment from my side. Is about where we stand, because today is a special day that I did not choose for this presentation, but it's a perfect fit, because it's not just that I get to present why I believe Gina is very sustainable. It's also where I got to share the news that we just launched our first major version today. And so it's been a very, very busy day for me, but this is definitely great news that I do want to share. I'm very, very proud of what the engineering team and the community itself have built over the past couple of months. And so I do hope you get to check it out. And this is my last comment before we go to questions. If you do want to get started, there's a million different ways. We have Twitter, we have a website, we obviously have GitHub, but which is actually not here. We also have a Slack channel. So if you do get started and you run into any problems or have any questions, we do have a really active Slack channel where you can also ask and get all your questions answered. Okay, that was the shortest 10-minute, hopefully only 10-minute walkthrough of what Gina does. Questions? Ooh. Yeah,
thank you, Lucia. And I can only, first of all, congratulations with your release. And I can only also kind of advocate what Lucia just said about the Slack channel. I happen to use Gina myself at my work, and I got helped multiple times in the Slack. So definitely check out the product. It works really well. First, I would like to start with some questions that I noted that I think are very, let's say, salient for our topic of today. And then if other people have questions, just feel free to post them. So the first one I had is that, do you actually, because you said that you have all this kind of executors and encoders predefined, right, in the hub? Actually, I was wondering, do you have any insight into how many people actually reuse like your predefined indexers or encoders, or how many are actually implementing their own? Because if something is implemented poorly, then it could be like not that efficient and not that sustainable. Let's say that one.
Right. So I think we're tracking some of the numbers. I don't have them in my mind, but I can tell you from experience of what I see is that I would say a solid 90% are using what we predefined, because they're going off of things that we built in examples. So that's basically the main thing of, I think, how I see people are using our product, is that they go from the examples and seeing how it works. And then the first thing they do is just tweaking the data input and output function and see how well it performs. And so I would still say pretty much, I would say I would I mean, I can't, I don't have numbers in my, like, I don't have the numbers, but even if I would check, I'm pretty sure it's like 90% are doing reusing right now.
Yeah.
Because we're also doing a lot of research ourselves. So like we have a couple of AI engineers that are always looking for new models. So especially when we have, for example, a Turk model that does object recognition, it performs very poorly right now. However, we are looking into how to improve, like we don't improve ourselves, but how to use maybe another model that that will create improvement. So yeah, we are always trying to get the best ones, and then people reuse.
Yeah. Yeah, and it kind of goes into my second question, because you mentioned this universality, right, that Gina kind of tries to pursue, and this, because you are able as a developer to implement your custom model, but how do we ensure efficiency there? And is there something that Gina has is an ambition or an ability to help the users with that, or is it more like you are yourself responsible about everything that you plug into our system?
Good question. Okay, so we have like there's I don't know if I'm answering it in the exact form that you're asking it, but so basically we do have so the thing that we've noticed why we're allowing people to add their own is because sometimes it's like they always using the pre-trained models like BERT and other ones that we are very familiar with, but a lot of people tweak it into their own, to like just a tiny little bit into their own use case, and then want to use that. And so what we do allow is to, like, we have some guides on how to use and leverage your own model and wrap it into a container and then use it in Gina. We don't tell people, like, we don't give them any guidance into what can be used and what not. Like, so it's pure free form. And I think that's always, I mean, that is a whole different discussion. If open source, how you direct open source to be most efficient. The one thing that we do promote is that if you have, we're promoting open source all the way. So we are all the way open source, but we're also promoting for the for community members to share their respective pods on the hub. So that's basically where we would love to see people go, so that they can be reused afterwards, so that not everyone has to come with their own pre-trained models. But that's obviously only guidance. We can't make them do that.
Yeah. Makes sense. Thank you. And I have one more question, which is more practical. What are typical use cases and applications in the industry for the Gina search?
That's well, anything that you can translate into search, that's quite a lot. What do I see are very easy to translate ones. So I see adoption in chatbots a lot, which I think also comes from chatbots being very popular right now. So chatbots work very well because they're Q&A, they're search. We see adoption in e-commerce, because e-commerce, again, search very big. But we also see adoption for these type of technologies and interest in Gina when, for example, when you have recommendation systems, and that can reach from anything, like we have recommendation systems, for example, in music. We're looking like, how Spotify and SoundCloud work. So they are very interested in these type of search algorithms because, again, universality of like audio as well. So we do have audio and video clips. That's an endless list, but I can, what else do it? Like, there's so many of them, but there's very easy to translate ones, or like very easy to come up with ones.
Yeah, and I think the last one for before we go to Ricardo's talk is which are the biggest sectors or major clients that you maybe can mention that are implementing the Gina framework?
So right now we are at early, so we have our first major version, which means we finally have a stable version, like fingers crossed. So we are at the stage of early adopters. And as I said, I think the early adopters are e-commerce ones, chatbot ones. Then we have, without saying what the client is, we have people in the doing text search. So NLP text search is also something when it comes to, especially when think of PDF search, or think of one like notebook search, where like you have a lot of big text, unstructured, semi-structured text data. But the other thing, actually, Mark being example number one, is finance industry. There's a lot of different people, different use cases in finance that are also very interested, especially when it comes to pulling together data from a lot of different data sources and then embedding it into like a similar space, and then have, for example, what we also provide is multimodality search, which means you can pull different types of modalities and search in the same space, which is very complex, but to say like you can have a lot of different data and search at it for it in the same time. So that's another big space. A lot of it is search. Search is very it's very big.
Everywhere.
It's everywhere. Everything is search. Yeah.
True. Yeah, absolutely. Thank you very much. I think we have a few more questions, but due to time, maybe if you would have time after the talk to just maybe react to some of the LinkedIn questions would be great. And for now, thank you very much again. And I think we can go next to the next talk by Ricardo, and then I give the floor to Natasha. First to introduce Ricardo.
Yes, thanks very much. Well, thank you again, Lucia, for this really insightful talk. And we're now moving towards the second part of the webinar. And that's all about using AI to reach the UN sustainable goals. And yeah, we're really looking forward to your talk, Ricardo.
Thank you very much for the introduction and for inviting me to present in this very nice event. Let me make sure that you can see the slides. Yes, right?
Yeah, we can see them.
So yes, the title of my talk is The Role of Artificial Intelligence in Achieving the 17 Sustainable Development Goals. And well, my work is, I'm based at the Lineflow Center at KTH, but I also work with CERC, which is the Swedish Science Research Center. So essentially, the research question that we wanted to address with this study is whether there is any published evidence of impact of AI on the 17 SDGs, and in particular on each of the targets that are part of those SDGs. So if you're not familiar with the framework of the Sustainable Development Goals, they were developed by the United Nations, and each of those 17 goals has certain sub-goals, which in their notation, those are targets, and there's a total of 169. So as you can imagine, this was quite a challenging work. We needed a quite multidisciplinary team to be able to address all the various topics. This ranges from, as you will see in a minute, from health to industry to biology. So we really needed so many different people with complementing competences, so we could really answer this question in the best possible way. And you can see, today I will talk just about the highlights, so kind of like some examples of how AI can help or inhibit these SDGs. But you can see the full study and a very detailed literature review in this work that we published around a year ago, more or less, in Nature Communications. So you can see the link here. And of course, I'm very happy to provide more information. Here's my email and my Twitter account. So I'm always happy to discuss more. A short introduction to our team. You can see the 10 of us here. You can see that it's very multidisciplinary. Myself as a fluid mechanics and applied AI engineer, but we have experts in AI fundamentals, interaction design, social and ethical aspects of AI, biodiversity, AI ethics, sustainability, and also we have Virginia Dignum, who is an expert in AI ethics, very well known here in Sweden, and Max Tegmark, who is also very well known at MIT, who is one of the visionaries of the future development of AI. So you know us a little bit better with this short introduction, and we hope that we could cover all the various topics that span the 17 SDGs. The first thing that we did was to take those 17 Sustainable Development Goals and split them into 3 categories. So it would be a bit easier to discuss and to try to see the impacts in a more global way. So according to standard classifications from the Stockholm Resilience Center or the United Nations even, we divided those 17 goals into goals affecting the society, affecting the economy, and also affecting the environment. So you can see the 3 groups here. And I mean, you can read the details of how we did the assessment in the paper, but basically we had a quite thorough peer review process, so we could really converge in our points of view to basically assess the literature on the impact of AI on sustainability. So in a very broad sense, kind of looking at the big picture, we saw essentially positive effect of AI on the SDGs. So if we look at the 169 targets, we saw that there is evidence, published evidence, of positive potential of AI on 79% of the SDGs. And there is, in principle, only negative impact of AI on 35% of the 169 targets. You can also see here split by categories. So the largest positive impact appears to be in the environment, and the largest negative impact of 38% is in society. I will talk more about this in a minute, but I want you to be aware of the fact that we say that there is a positive impact, and there is more positive impact documented in the literature, but it does not mean that there are not risks. It could be that one of the targets is negatively affected by AI, and that has catastrophic consequences. So in this kind of classification that we make of 79% positive, 35% negative, we should be a bit careful, because one negative target could really have very strong consequences, overwhelming all the positive effects of AI. So this is very, very important. And if we look in a bit more detail, here you can see on the left, for each of the 17 SDGs, what is the percentage of targets that are positively affected by AI, and on the right, the same, but with negative effects. And you can actually see, I don't have so much time today to talk in detail about the difference between this shaded region and the kind of lighter region, but basically the shaded region was an analysis where we took into account the strength of the evidence. So if you are interested in that, we can actually discuss it a bit more later. Just what this shows is that if one takes into account the strength of the evidence, one sees that there is much more research needed for the economy. So the positive or negative impact of AI on the economy is not fully documented. There is much more research to be done, and in particular when it comes to long-term predictions, to really, really have strong statements regarding the impact on the economy. The impacts on the society and on the environment are a bit clearer from the perspective of how strong the evidence is. And some key results or some examples of one positive effect of AI on SDG 1, on no poverty, is, for example, AI-enabled technology for example, to fight poverty. So this is, there's quite some evidence that using satellite data, one can track poverty and hopefully develop coordinated actions to be able to have better plans and mitigate some of these negative effects. However, when it comes to inequalities, AI can have a negative effect that will affect SDG 10. And if one thinks that the future will be fueled by AI and we're going to depend on AI to really develop all this potential that we can have, we need to make sure that the access of AI is kind of evenly distributed, because if not everybody can access these resources and not everybody can really exploit them, then we're going to increase the currently large inequalities worldwide. So this is one of the, I would say that this is kind of like the summary of our study. AI has huge potential, but one can have this increase of inequalities, and that technological development that we can achieve can be really, really overwhelmed by that negative effect. A couple more examples, and this is, of course, in these days of Corona, a very good example of this is how one can see political polarization. I mean, we use social media all the time, and the social media is filtering the type of news that we read, the type of content that we consume. So this can really lead to polarized societies. And as a general conclusion, I think that a very important take-home message is that regulatory oversight should be preceded by regulatory insight. What is that? People who are making decisions regarding regulation of AI should know about AI and what it can and it cannot do. This is important because if people who are making decisions are not aware of the details or kind of like the potential of AI, we're going to have a policy that is going to be counterproductive. So it's very important to involve more technocrats in policy making and in decision making and that we can bring as many people as possible into the discussion, and mostly to basically send the message that we are all concerned with AI, and we are all interested in having such a discussion and such a debate. So this I think is very, very important. And I'm very happy to be in events like today where we can share and we can discuss and try to see what are the relevant points and what are the risks or dangers of AI. This slide summarizes a little bit the interactions that we document in our study. Basically, well, technology has a very fast pace of development, which essentially what produces new needs in individuals that require legislation. So, and then governments essentially are well, slower in reacting to this fast development of technology. So in a way, the cycle works as technology being very fast, individuals lagging behind technology, and governments lagging even farther behind than the needs of those individuals produced by technology. And in this framework, the environment acts as a layer where all these interactions are taking place. And of course, in terms of the resources that we are using as well. So this goes back to my previous statement that it's important to regulate, it's important to have good governmental bodies to be able to develop appropriate policy and to have technocrats in those bodies. To finish with a kind of happier and also more technical note, one positive example, which I work also quite technically in my research, including mechanics, is the positive impact on SDG 11, sustainable cities. I mean, air pollution is a big problem. It causes 800,000 deaths per year in Europe. And a huge percentage of the population in Europe is exposed to pollution levels much higher than recommended by WHO. So this is really, well, an area where one can do something and one can help. Kind of in a very summarized way, the idea is to do non-intrusive sensing in urban flows. So what you see here is a very detailed numerical simulation. So basically, we can really recreate the flow in this case, in a simple urban environment. It's only one building. We will see more examples later. And the idea is to train a neural network to predict from sparse measurements the three-dimensional flow, not only the flow, but also the concentration of pollutants in that flow. So that's something that we have been developing for a while now. We have one example that you can see here. I will not go into all the technical details. I can answer the questions later on, but you can see some of this work in this article by Wastoni and others in the Journal of Physics conference series. In this example, we have a simplified turbulent flow where we use information at the wall to predict the flow farther away from it. And to do that, we use convolutional neural networks, as it was mentioned in the previous talk. I mean, these networks are actually very nice for image processing, and in particular for flow features, because these networks can exploit the spatial information in the data. So we can actually, if you compare here, this is how the flow looks like far away from the wall. So this is what I'm trying to predict. In the center, you see the reference. So this is what I am aiming to get. On the bottom, this is what I get with convolutional neural networks. And on the top is what I get with traditional methods. So you can see that I get an excellent prediction with neural networks. And the reason for that is that neural networks, kind of going a bit more technical, they are able to produce nonlinear predictions, in this case, nonlinear relationships between the input and the output, and that allows us to reproduce some of the nonlinear interactions in the flow, in this case, in a simple flow, but this can also be applied to cities and to more complicated to airplanes and wings. So we like in engineering, and in this particular case in fluid mechanics, we like neural networks because they allow us to have nonlinear predictions, and this nonlinearity is inherent to the phenomenon that we are trying to model and to predict. And here are a bit more, kind of like a bit of a more elaborate prediction framework. So here on the right, you can see very detailed numerical simulations with two obstacles where I have different obstacle separations. And this type of data can be used to train a neural network that can produce predictions of the flow and of the pollutants based on few sparse measurements. And this is ongoing work, and we are having very promising results in terms of going from few measurements to a denser input and then to a three-dimensional representation of the flow. But this is important because then this can really constitute a revolution in sustainability in cities worldwide. So this is a very promising approach that we think can really help. I have a little bit of time. I wanted to briefly mention another example of a data-driven method. This is a COVID-19 example for these contact tracing applications that have been developed, and some of them have been deployed, and how it is very important that these apps respect the privacy of the individuals, basically in terms of data collection and data storage. And for that, we have to avoid centralized data gathering with a DP3T protocol. This is one of the biggest conclusions that we can have from this study. And we evaluate some of these apps with a framework, an ethical framework of how the data is gathered in these apps. Again, to make sure that we fulfill the sustainability requirements and also the ethical and privacy requirements of the individuals. If you're interested, we have much more information in this article reference that you see over here. And these are my conclusions. Perhaps one last comment, and is that we should, it's very important that we are aware of what AI can and cannot do, and that we try to develop better solutions as a whole to really exploit the positive effects, the positive impacts. For example, if we know something about the physical system that you're modeling, you should embed that in your AI system. You should not allow your network to learn it, because that's, first of all, going to give you worse results, and second of all, that's a waste. And well, in our study, we also show the electricity consumption of AI models is going to increase exponentially in the next decade. And of course, that's also one of the responsibilities that we have to develop AI sustainable models to really keep the computational cost and the electricity cost to a reasonable level. So I would like to thank you very much for your attention, and I'm looking forward to answering your questions.
Yes, thanks a lot, Ricardo, for this really interesting presentation, and also shedding more light on the positive, but also the negative impact of AI on our sustainability, on our society, and also how we can, of course, like reach those sustainable development goals. And so I see actually there are quite some questions from the audience. Maybe we can just address a couple. For example, there was a question by Joren on how do you quantify the impacts, and how do you weigh positive and negative impacts?
That's a very good question, and I should have a slide for that. Okay, yes, I have it. That's very good. I don't always have time to talk about it, but I have the slide as a backup. So we had a very, you can see my slide, right?
Yeah.
Yeah, good. So we had a peer review. So we all were digging into the literature. And first of all, we were classifying the references that were mentioning positive or negative impact of each of the targets into these 4 categories, where we call the type of evidence, basically. So a study where there is very strong evidence and is very sophisticated method and is reproducible to large scale, that's a type A of evidence. Of course, the more speculative that reference is, or the less robust that the results are, then we give kind of like a lower grade, not B, C, and D. And what we do is that we give a weighting factor going from 1 to 0.25 according to the strength of the evidence. So, of course, if you have a study that suggests very strong evidence, that will be one target being addressed positively or negative by AI. And if it's a very weak evidence, then only 25% of that target is being addressed. That is actually, if I go back to the beginning of the presentation, that is actually the difference between the 2 regions in the results part. So the outer circle, these lines over here, the outer ones, do not take into account this weighting, so they take all the references in the same way. And the darker results that you see in both cases, those ones take into account the weighting. That's why all the values are smaller when one takes into account the strength of the evidence, because some of them are just more speculative. So that's a little bit what we try to do to take into account the strength of the evidence. And of course, I mean, this is not an exhaustive assessment of the literature. We were trying to find at least one study that was addressing each of the targets. In the end, we found hundreds. So you can see in the supplementary material of our paper in Nature that there is quite some reference that we had. But we thought that this weighting process helped us a bit to make stronger statements.
Yeah.
So this is a very good question. Thank you, Joran.
Yes, thanks very much for providing the background on that. And now that we're already at the beginning of the slide deck, I actually just had another question on how do you track the poverty with satellite data?
That's a good question. And that's also, I mean, you can, there is a study by John and others in Nature where they do that. And it's in the end a similar method to another recent study where they found trees in the Sahara, for example, right? And in the desert. So by analyzing the data and correlating it with other indicators, socio-economical indicators, then they can really see what are the, at the end, at the pixel level, what are the images that are correlated with more indicators corresponding to poverty. So in the end, it's using multi-dimensional databases and a lot of image processing. And of course, the authors who did that work in Nature, which you can see also in our article, then they can also speak more about that. But that's essentially the idea, to correlate those images with the socioeconomical data that is related to those areas.
Yeah, very interesting. So I think we have time for one last question. I see a very specific question from Josko, and he says it's really interesting, slide 14, and he says he's curious how the Reynolds number interacts with the model. Is it a model for each Reynolds number? And how much information does it need to get accurate?
That's a very good question. Let me go back to the slide 14. I have different screens here, but I think I can arrive. Yes. So that's a good question. The idea is that we use transfer learning for this. What does that mean? Well, transfer learning, this has to do also with the questions about in the first presentation about generalization of these models. We train this network for one Reynolds number, and then we initialize the training at a higher Reynolds number with the weights of a lower one. So in principle, they are different models, but what has been learned at a low Reynolds number is transferred to a higher Reynolds number. Like that, we can reduce the training time by 75%. And another thing is that I don't have the details of the network here. You can see more of the details in the reference, but one can also freeze some of the layers and train others. We know in turbulence that the smaller scales they have a more universal behavior. They're not fully universal, but they have a more universal behavior. So if you fix the first layers, in this case, we have 6 layers in this convolutional neural network, then the large scales, which are more varying with boundary conditions, with the Reynolds number and so on, those are the only ones that are trained. And by doing that, then we can also significantly reduce the training time and the training cost for these models. So, I mean, it cannot be directly applied, or if you directly apply one network trained at a low Reynolds number to a higher Reynolds number, if you scale things properly, you can apply it and you will get something reasonable. But if you do transfer learning, meaning that using a little bit more training data at that higher Reynolds number, then you will get significantly better results. So that's basically the key, the transfer learning.
Yes, great. Thanks very much. I see there's a couple of more other questions, but unfortunately our time is limited, but it would be great if you could just maybe after the webinar, just go on the LinkedIn page and then provide a couple of quick answers to some of the remaining questions.
Absolutely.
Yes, perfect. Thanks a lot. So thanks very much again to both Lucia and also you for your talks, and also, of course, answering a lot of the questions from the audience that were put forward. So we really enjoyed the event, and we hope you did as well. And to thank you for your efforts, Xamnia has sponsored actually a gift card from Etsy, which is a ethical website where people can sell their own handmade products. And so you can, they will be sent to you after the webinar instead of flowers. So we hope that you can enjoy that. And thanks very much again to you both.